I'm going to introduce Enrique here, who is a famous person in Seattle and does just awesome stuff for the community. So I'm going to just read it off of it. For 13 seasons, Enrique was the executive producer and host for the award-winning weekly current affairs program, KCTS 9 Connects. I actually was watching him when I was littler, and on Conversations, which is one of the shows that I really enjoyed watching the thought leaders talk one-on-one with him, and so we're really excited to have him. Moderated statewide broadcast, public radio, television, 2008-2012 governor debates. My wife watched that. I'm getting into politics. And also the U.S. Senate broadcast debate 2012. So Enrique has earned 5 Northwest Regional Emmy Awards and numerous other honors. The Seattle Weekly said he was the best TV host, and Seattle Magazine named Enrique one of the most influential people of the year for his broadcast work. My wife is Hispanic, and their family just saw some of his recent work on the Hispanic community in Eastern Washington. So if you guys want to watch that, it's pretty awesome.
Thank you very much.
Do you need a mic?
Well, I think we're live here. Are we? Great.
Is the mic there?
I always like when people introduce me. Just how long I've been around here. Good morning. I think we have an opportunity here to have a lot of fun. And also, we have a great location for this. I mean, look, there's no rain. There's actually a little bit of sun. Soak it in now. And just a beautiful setting there to be able to watch the ferries and the boats here through the windows. But I appreciate you all being here on this Friday morning as we are going to have a good conversation. Let me introduce our panel members this morning. Right here to my left, immediate left, Mark Dietrich, Data Center Solutions Architect, Brocade Communications. Brocade Networking Solutions helps the world's leading organizations transition smoothly to a world where application and information reside anywhere. And also next to him, we have Nilesh Landi. He's the founder of CloudGenius. CloudGenius is a team of professionally trained instructors at various universities. They created and have enabled IT professionals to acquire cloud DevOps skills and also to land jobs, very important. And next to him from Microsoft, Abhishek Tiwari, Principal Lead Program Manager at Microsoft's Data Center Networking team. He has more than 15 years of experience in networking industry and including different development positions in networking startups such as Com21 and Vivace Networks. So thank you very much for being here. We appreciate it very much. Well, we have a top 10 list of questions here that we'd like to have our panel members weigh in on, and then also we're going to have those of you in the room that are here to ask questions of them a little bit later. But let's start with this. What is your definition of software-defined networking? Let's start with you, Mark. I think we're going to share the microphone there.
I think there's a loaded question because the standard one is that the control plane and the data plane are separate, but I think it's much more than that. What I think is that Ethernet networks have not really changed in the last 20 years. They're still working the same way they did. So there's been a lot of innovation going on to make Ethernet networks better. For example, Ethernet fabrics, which is something Brocade has developed, but what really needed was a way to do network virtualization. And there's been network virtualization for a long time, like MPLS, in which you have one large infrastructure, but you want to have multiple virtual networks on that infrastructure. That's what MPLS gave you. But we need to go farther than that. We need to break the network into tractable pieces. And we do that by modularizing using abstraction. So if we take our physical network and we can abstract it and let a controller that communicates below through that abstraction and above to control programs, now we have the ability to allow software programs to do a lot of stuff for us, such as manage it and automate things and monitor things and optimize things, makes things more efficient. So I think the definition is that SDN allows you to programmatically control your networks in such a way that you gain efficiencies and simplicity and certain assurances.
Thank you. So my definition is a whole lot simpler. It is basically in the... Yep.
Larry?
Okay, let me go closer. So my definition is a whole lot simpler. I think of it from a perspective of separation of concerns, like you already mentioned, separation of data plane versus control plane. That's the classic textbook definition. But if you apply these concepts to like three things: compute, storage, networking, we're already seeing these kind of virtualization trends happening, and these things are not really new. I have seen LPARS in 50 years ago in IBM mainframes. You've seen that virtualization of CPU. How do you divide that? Same concepts and principles being applied to networking, where you are able to manage large-scale networks almost from a conceptual and policy level to bring economies of scale to any use case that you have in mind is what is being driven. And the word SDN essentially stands to bring economies of scale in networking by virtualizing the underlying resources. That's what we see it. Thank you. Yep.
Thank you. So I agree with Mark and Nilesh. SDN has a different definitions, and each one has its own definition, as both of my colleagues said or peers said. SDN is about separating the control plane versus data plane. But if I truly see in the business sense, if cloud is a vision to achieve reduce your cost and then get to the scale, then you don't want networking to be a bottleneck there. You don't want those fixed hardware should create hindrance to provide that flexibility you need. So in my view, the networking vision is about delivering the network as a pool of resources. The way you see the other virtualized resources, you should see a network as a pool of resources which can utilize as and when you need it. At the same time, the networking should give the flexibility and control both to the cloud operators and the business side of it. The control which the enterprise want to have it on their physical network, they should be still able to have the same control and flexibility out there. So the isolation, security, and all that aspects, it's are essential. And then allow the seamless migration from on demand. When you're the capacity increases, you should be able to do it seamlessly. When you want to roll it back, that you should be able to do it. Things you should not worry about your services being continuously available. It's the disaster happens, you need to do a whole lot of investment. So SDN is a different components built together to provide, making sure your network is a utility service, always available to you without you worrying about too much. That's in a broader sense, my definition of SDN is.
All right, let's move on to our next question here. And that is, how has SDN changed the landscape for IT administrators in end user control management? Go ahead, Mark.
Well, it could change the landscape by, well, let's start with what we have today. We have networks that are extremely difficult to manage, extremely difficult to evolve. They're very difficult to get new services deployed on. So what we want to do from a network management standpoint is we want to get to a point where we can do these things faster, quicker, and more efficiently. So what SDN will do is enable those things to happen.
Okay. Nilesh?
So thinking from the perspective of IT managers, the idea is to let them focus on bigger business problems than going into terminal sessions or some kind of a browser window or control administration where you go and modify certain aspects. to alleviate the trouble of managing and maintaining these network resources and letting them focus on bigger policy level or complex problems is the need that we have. Now, I think SDN and the evolution around it and the industry is approaching that direction, but making it mainstream and making it cost effective to the point of economics that in every industry segment where these technologies are used, once they become applicable and programmable so that the IT admins do not have to do manual work, the grunt work that's associated, some of it can be, if you can eliminate that aspect, will free up the IT administrators' time available to them so they can spend on bigger things in life for solving their business problems. I think that's the position we'll see in the upcoming few years. We will get there pretty soon.
So yes, I mean, I see IT admins focusing on the value providing to their consumers or to the end user, which is like, focusing more on the application side. I'm from the engineering side, so I like take the example on the technical side. For example, if there's your company going for an acquisition or expanding, right? You should be worried about how to provide, different, business applications being available seamlessly to you new set of audience rather than worrying about, oh, what kind of this acquisition this networks brings on, and then what kind of challenges I should, deal with it, what kind of addressing space it, handles it. The SDN allows IT to, forget all these challenges and then, have the seamless expansion of their networks in terms of, the management of it, monitoring aspect of it, scale and availability, and then focusing on their end value by applications, focusing on the services they want to deliver to their end users and customers. So that gives IT admin to play in a different level than focusing on the nitty-gritty of the network. That's how SDN is changing their life.
All right, let's move on to the next question. You keep the mic right there, and we'll start with you. Okay. What's the applications for SDN? Home, wireless, cellular, enterprise, data center, backbone networks?
All. I mean, I would say SDN is applicable for all. It's like SDN is it's applicable. Of course, people associate with the SDN for data centers, obviously. Sorry, data center, and then all the things we read and then discuss about it. It seems like SDN is really tied with data center technologies. But I believe SDN is being discussed in the forums like telco, carrier operators. It's not just the data center aspect of it. We have heard the private data center and then private cloud, which is very much focusing on the enterprise side aspect of it. We have seen how application from the Microsoft example like Lync, Office 365, Bing, all these are the first class applications which are leveraging SDN. So. And there is an example on the Lync where I always give it. The SDN uses the Lync delivering the quality of service to end user, figuring it out which network you are connected and how they should play with the quality of service, including different equipments that come or devices that come between the end client and the server, and then tweaking automatically without the IT admin to be worried about these things. So I would say SDN is applicable to all segments of the technical applications.
Right.
So the primary applications, as Abhishek already mentioned, it's almost in every industry, including all the way from your homes all the way to high-end enterprises, backbone operators, carriers, specific situations where people are deploying public or private clouds, cloud providers. All these segments of the marketplace in the industry are using these technologies already. The biggest impact that we will see is probably in the space where people are deploying private clouds within a context, or large companies who are already deployed public cloud. You will see a lot more value is there in this space using SDN. You will also see carriers like Level 3 or Comcast, the big name pipeline carriers that carry the bulk of network traffic. They also stand to benefit a whole lot by using these technologies. Another interesting use case is in the financial services industry where trading happens at a very low latency, and that has another unique application, especially in the New York area. You can see some implementations there if you go there. Thank you.
Okay, so I hope you don't mind if I refer to a list, because I did jot some things down, and there's so many applications that you can't really put it into these categories because the lines are blurred across so many things. But there was a survey done recently, and one of the things that customers want to see is just regular adds, move, changes, and deletes in their network. If they could just do that alone, they would be very happy. Things like VLANs and ACLs and QoS being set up, enabling, disabling ports. Service chaining, traffic redirection into middle boxes such as firewalls, IDS, load balancers, WAN ops, proxies, encryption boxes. That's big. Public and private hybrid clouds, which was already mentioned. If a user goes to a portal to light up a VM and he needs access to the network, that has to be done automatically through software, right? So we have things like OpenStack and VMware's NSX in order to enable self-provisioning portals. And then to be able to move VMs across boundaries might require SDN as well. Multi-tenancy is another thing that is made much easier and automated with SDN. DevOps is a big one. In order to be able to do development work on a network and logically isolate that from everything else can be done with SDN. The list for security is huge. DMZs, in order to direct traffic properly through DMZs. Isolation, denial of service attacks, distributed denial of service attacks. Brocade has demonstrated the use of SDN in this area. In fact, we just won an award for best product in that area. Monitoring, logging, surveillance, network access control like 802.1x, role-based access control based on the person who's logging into the network. Application-based network access. So let's say a backup application starts and that backup application needs a certain amount of bandwidth, you could do that. Communities of interest is another one. Being able to manage SLAs, QoS, content delivery, so the monitoring of that, the traffic engineering, the policy enforcement, what else? And deterministic paths through a network. So if you want traffic to take a specific path through a network for whatever reasons, and there could be all kinds of reasons, and these could be changed from time of day or service provider, WAN provisioning and the re-optimization of flows through the WAN can be done with SDN. Bandwidth pools, so you can pull together bandwidth from multiple service providers. Hitless and nonstop graceful network upgrades. Traffic mirroring is another one, so that you could do logging, analytics, audio and video, diagnostics, that type of thing. DR, backup services, migrations from data center to data center, service monitoring, analytics. And I know I'm starting to take too much time, so I'm starting to gloss over. There's more things. There's a lot of things that SDN ultimately can do.
Very good. Let's move on here. When will we get to the point where we can deploy networks and services more quickly and efficiently? I want to start with you, Mark.
That's a good question because this technology is in its infancy for sure. Now we have, at least Brocade has technology called hybrid port technology in which the switches and the controllers can be installed today, but you're not all in, right? You're using a regular Ethernet switch to do traditional switching, let's say in your data center, and when you want to switch a port over, you could either make that port entirely an SDN port, or it could be a shared port between regular traffic and SDN traffic so that you don't have to go all in, right? You can go in as needed on a per flow or per application basis, and this is a good way to get into it. So I think the answer to the question is it could be done today, it could be done now, and it could be done in such a way that you could do it at a pace that makes sense to you, and you could try things and test things as you need to.
All right, move on.
So this particular question was in the context of a word "we," as in who we are, and that depends on the aspect of, if you look at the adoption of this technology in the industry in general, if you look at the adoption of this technology industry in general, what you'll observe is there are some early adopters that are already doing what you ask in the question, which is, hey, can I deploy SDN and have my problem solved using the way that they have in mind? So it depends on who the we are in terms of the early adopter versus those who will follow the leaders and those who will actually adopt when it goes in the mainstream at a very good economic price point. So the answer is yes, it is available today, but not everybody is ready to adopt because it is still bleeding edge. It is coming.
So I'll take from the Microsoft point of view what we have it today, and then of course it's a journey, it's a start, and then we have a long way to go. But what we have today, and then what customers use it, we have a extensible vSwitch, which is like, sits on a Hyper-V host where you can put all your forwarding policies, security policies, your filtering and capture extensions. So basically our switch, which allows, for the data center admins and then tenants to deploy the policy they see day to day in their enterprise network. We also, as part of our solution, let customer bring in their own network to the cloud, not changing their IP addressing or anything. We have our overlay networks, which we call it Hyper-V network virtualization, that HNV solutions allows you to bring those networks and get it connected back to your on-premise. So it's not like, you are creating an island which talks like, within that island. Our HNV solutions has a edge connectivity which lets you talk to your physical network, your VLAN networks, your MPLS terminated edge. We provide an orchestrator in form of SCVMM that lets the service provider admin, the tenant admin manage networks seamlessly the way it should manage your QoS policies, your port heckles. And this all we do to ensure you don't have to touch your physical infrastructure. So these overlay networks are put in a way that your existing physical infrastructure doesn't have to change. That's what Microsoft provides today. We are dealing with our partners both in ISVs and IHVs world. We are providing the technologies where NIC can be leveraged, doing things faster. For example, IOV, the virtual machine can bypass the entire stack and then do things from the NIC at a speed of 40G or 10G. We work with on our storage on the RDMA, our SMB direct solution that lets you access your storage much faster than what a regular software TCP-based stack would do. And this all we do to ensure you could still manage your policies, which are QoS policies for storage traffic, provide the right set of isolation for your tenants. So in short, the customers have these technologies available today to leverage SDN. But we are not done yet. I mean, this is a journey and we would be doing much more. We are partnering with our communities to make sure we have a same standard, and then the ecosystem is evolving towards that. But yes, I mean some sort of SDN is already available, and there are many many even Fortune 500 companies are using one or the other form of SDN already. And I haven't given the example of our own Azure and the Office 365, which are big into this whole SDN world, and they have their SDN solutions deployed for 3-4 years now. So I mean, we have first had an experience how we can get the benefits from the SDN.
Next question, we'll keep it with you there. What is the Open Network Foundation, and how are they involved in SDN?
So Open Network Foundations, again, coming back to the Microsoft point of view, I mean, We want to ensure there are, I mean, two things which, right now the industry is dealing with. One is about the open source, and then one is about open standard. And I just want to give touch base examples on both. We are working with both open source and open standards. But our priority is to ensure, we work with the open standards. That ensures that, when we develop a solution that interops with any other ecosystem or, the applications that play a role into the SDN. So that's how we ensure the entire openness into the SDN story, which is including open systems and then the open standards. We are working with, for example, Open Daylight. We are a platinum partner with Open Daylight, and then we want to ensure their controller can work with our VMM, which is our orchestrator, and then manage our Hyper-V switch. I mean, that's the dream we are going for it. We are working with open flow, and then ensuring we have a right set of standards and working with the communities, the application and implementation happening in a direction which we believe is a right direction to go for it. So we believe it's very important, and then we are participating from the Microsoft point of view.
So Open Network Foundation essentially is a community that is driving standards, enabling the industry to come together to interoperate properly and achieve what I would like to envision, a goal which is to commoditize the essential elements that will bring more value to the end user. So once have industry players interoperate nicely and come to an agreed upon standard, that leads to more value generation for the end user. And that's the community that's driving this effort in this space.
Yeah, the ONF is the stewards of OpenFlow, and they're defining it. They're making sure there's interoperability among devices, and they're promoting SDN in general. So that's pretty much their charter.
Yep. Keep it right there with you, Mark. What are programming languages, verification techniques, and tools for SDN?
Well, some of the controllers are using Java, and some are using Python. I believe Open Daylight, which Brocade is very involved in, is using Java. And as far as the verification techniques and tools, I have to admit that's not my bailiwick at Brocade, so I don't really know how to answer those two. But I know what the programming languages are.
So the ultimate goal behind SDN is to have it interoperate with any programming language that people would want to use with. So we already have Java, Python, Ruby, C#, .NET. All these languages are coming along at various stages of the development as SDKs develop that will let developers of these networks create solutions for the end users. There are tools that have come up, like the classic, for auditing and verification tools like Nmap is very popular in the open source community. And from my university, University of Michigan, there is a recently developed new tool called Zmap, another open source product, amazingly popular and powerful, that can scan the entire IPv4 address space in like 45 minutes. You should look at. It's open source tool called Z, as in zebra map. So that's another tool can be applied and deployed to make use for verification and audit purposes in a situation like this.
So question is about programming languages and then verification techniques. If I just see the SDN and then the answer, the programming languages, SDN typically has the stack on the orchestrator, which is a northbound side, which talks to the different management applications. And there are programming languages like Java and others, people can write their northbound interfaces. Idea is to make sure industry moves towards a standard northbound interfaces. So these application developers can write their application and then can work with any SDN stack or controller stack you have. Programming languages should not matter ultimately, and that's what our belief is. And on the other side, on the controller side, towards the devices, we have the southbound APIs where you talk to different network devices from like, Brocade, Cisco, F5, Citrix. And again, the way you want to make sure the application developers won't have to change it, same way you don't want based on the network, the SDN stack you use, kind of change your interaction with these devices. So the ultimate goal is to, again, works towards some sort of a standard schema, a standard protocol, to make sure the management of these devices simplified. Microsoft participates in the Open Daylight, so I'm looking for a Java support as well. We have applications written on C#. We have scripts written on Python in some of our efforts as well. But ultimately, I feel like once we have a common schema and standards towards these interfaces, these things would be irrelevant, should be irrelevant, how they are written. Tools, we have different tools. The most important tool is about, in the SDN, is about ability to monitor and know your network. And there are different tools. I mean, from the Microsoft, we provide the Ops Manager in the SCOM part, which is a part of System Center Suite that can manage your network, that can monitor your network. VMM is the management aspect of it. There are protocols to give you the deep insight of your network, like NetFlows, IPFix, that runs like the various stats and then the information that can put into a collector and then provide information about usages, diagnostics, and other things. And there are basic networking tools like which day-to-day people use it to verify and then ensure your deployment is right. So that's it.
Move on to the next question. We'll go to you too. How do you see projects like OpenFlow influencing and/or growing with the proliferation of SDN?
OpenFlow is important. OpenFlow provides I would say a reference implementation, and it's available so people who are looking to build their own SDN solution or at least thinking of adopting SDN, they have some sort of reference implementation available. It defines the standard, defines the flows, it defines the tables in a format where people can see how the policies and then data plane should work. So that way, given that industry is still new and then people are just trying to adopt it, having an open flow and then which is going towards not just documenting it and then having in some sort of form it's available, it definitely helps people who are thinking about it or in the early stage of adopting the SDN or the cloud vision.
So the idea behind here is to look at what I would call a North Star or a compass in your hand in the industry where everybody is marching towards that same goal of accomplishing a common standard. And that's where this community helps in the industry, is to help manufacturers of devices and components and services drive towards that common goal to enable SDN.
I think OpenFlow, they have a long way to go, right? Let's start by saying that right now I don't believe there's a way for the switching infrastructure to communicate back to OpenFlow what capabilities it has in order to change what's communicated from OpenFlow to the switching infrastructure. Now, it's not that won't happen sometime in the future, but at this point in time, that doesn't exist. So that might get remedied. Also, with OpenFlow, there's an assumption that being open is what everybody wants, and I think it's a nice to have for most customers, but if a particular manufacturer were to come up with a proprietary solution that was significantly better and supported maybe in a different way or in a better way, that is not something that a lot of customers would turn their back to. And I'm in no means implying that Brocade's going down that that path. We are working with OpenFlow, actually, but we are concerned about the future of OpenFlow and how it's going to work. OpenFlow, as it matures, may require that silicon evolve as well. I do not believe that in the future switches are going to be commoditized, off-the-shelf, dumb devices. That's pretty much not going to happen. And if you're thinking you're going to buy switches for a couple $1,000s that could do this, that's probably not where the savings is in SDN. The savings in SDN is making your networks more efficient and reducing the OpEx. That's where the savings is, because you're always going to have competent switches for this to work properly. And those competent switches are going to be made by the big switch companies that have the technology and the resources to build them, and the switches are going to continue to have to do things on a switch level. For example, flow control. Let's say you're doing data center bridging and you need flow control between switches. That can't be done by a controller, because the controllers are not fast enough for the switch to send information to the controller to figure out what's going on, and then send back to the switch, hey, slow down your traffic over this data link before the amount of time that your buffers overflow. It's not going to happen, right? So the switches have to be competent, and that's just something to take into consideration, right?
How does SDN fit into the concepts like Internet of Things?
Well, the Internet of Things refers to an explosion of devices that are out on the periphery and into huge numbers. In order for networks, like carrier networks, for example, to accommodate these huge number of devices, which a lot of them may be moving around, right? So they're going to move from network device to network device. Now that's something that a controller can actually manage, the movement of these devices and the quantity of these devices. I think a lot of this, there's two ideas behind SDN right now. There's you make these tunnels between the edges, and everything in the middle is just switching, and everything is done on the edge. Or the controller actually is communicating with every intermediate device from end to end and managing it. There's pros and cons to each. If every intermediate device needs to manage every flow, there is some scalability issues that need to be taken into consideration. If you're just doing the end devices and you're tunneling from edge to edge, then you kind of lose control of traffic engineering in the middle part of the network. So there's pluses and minuses, but that's how I see SDN with the Internet of Things, is managing these huge numbers of devices.
So Internet of Things is the catchword, buzzword these days, and I have examples in our hand. Like, I am actually connected to my car that is parked downstairs, and I can operate my car. Now, the concern I have as a user is to be able to see where my car is and see if it is at the right temperature I want it to be. There needs to be an internet connection from the car to the phone, and same concepts applies to, say, I have this Nest device in my thermostat in my home. I want to be able to connect to these things from a user's perspective to be able to identify whether I'm able to connect. So the connectivity aspect, the throughput aspect, the discovery aspect, the security aspect. I don't want anybody else to barge into my car parked downstairs or interfere with through a network or attack my car on the internet. So these aspects of security needs to be taken into account. Now, the concepts that SDN provides, these network operators, like, take the example of this Tesla company providing the cut services for my car, the phone company providing connectivity to my device in my hand, Google, which now acquired Nest, they are providing these services in my home. So these elements, the devices, or Internet of Things that is being formed, is being developed today, what SDN can do and is doing already is to providing the core elements of security, being able to access, being able to identify who can access what, when, and how, and why. All these aspects around aspects of making sure that the fidelity that a user expects from access to a device from edge to edge or edge to hub or the main, these elements need to be controlled in a methodical, systematic way, and that's where SDN plays a game for these large providers today, and it'll come down mainstream pretty soon.
So Internet of the Things, I mean, if I purely look from the SDN point of view, there is always a controller aspect in the SDN. And when you have these devices, take an example of different devices at your home, maybe like, the different internet devices like, your tablets, your PC, your phone, your IGD's box over there. You need some sort of a central controller to ensure that understands your requirements, and then that control, if I'm purely talking about network perspective, that understands your requirement now and control your network settings for you without you getting worried about it. The things you are doing with, like, it utilizes, like, what kind of services you are running, and then how you ensure your DSL router or your cable modem is best utilized as per your current need. It's also SDN controller about the same thing what we are facing challenges. It's like guiding towards a standard protocols. Like, these devices are coming, and then they are coming in a way where, like, people having their own implementation, and it would create a challenge when a central entity wants to control and then provide a common experience across. The third aspect, which is again, coming back to the data center, which is important. Right now, our life is, like, somewhat dependent upon the cloud services. So at least I imagine a world where there would be some sort of cloud services where, like, I can control the different aspects, whether it's my car, which is parked at office, whether it's like thermostat, which is at my home, or my wife, which is having a different cell phone, or my kid who is having some other gadgets out there. In these different remote places, having a different set of devices, but still have an ability to control things, manage things without spending too much time. So SDN, same principle. It brings simplicity, it's seamless, it's irrespective of location, it controls different set of devices. So I think in the Internet of Things, same concept, and then challenges and initiatives which we are doing for the data center SDN, gonna see in the Internet of Things as well.
Let's do one more question, and then I think we're going to take some questions from the folks that are here. How do you evaluate SDN network elements and controllers?
Evaluate in terms of, so there was a question out there, like, how do I evaluate SDN on the performance? I'm not sure performance is the only aspect of SDN. People think, oh, my, like, with the controller I perform, this is my, the throughput rate, or this is the, like, how fast I control, manage things. The overall evaluation should come about end-to-end management, end-to-end deployment of the SDN. So when I look for the SDN stack, the way Microsoft provides it, you need to have an orchestrator and a management layer that can, for a different set of admins, tenant admin, service provider admin, hoster admin, application admin, right? Like, these different set of admins can then do their job without getting exposed to the complexity of networks, if, like, from the SDN point of view. Then I see, sorry, I was, like, I was missing in the actual question aspect of it.
How do you evaluate SDN?
Yes, sorry, yeah. So then it's like, on the management aspect of it. Then I would say there are set of business policies, and then this SDN should be able to let me put my business policies in terms of business terms, rather than, like, me being a network expert and then defining my business policies in terms of network. So for example, I should be simply able to say, these are my web servers, this is web servers, it's like connected, and I want to make sure this is available all the time, and it's providing the continuous availability, and I should get a stop there. And then SDN should be able to, the stack should be able to convert that business aspect or policy in terms of what kind of network requirements we have. The SDN is also about how I can manage the end devices, which are different network appliances, whether it's your gateway, whether it's your WAN optimizer, whether it's your firewall, whether it's your DDoS appliances. We initially developed these appliances in a world where they were deployed in the enterprise level, and they were having the complete control by the one enterprise admin and meeting the requirements of one admin. But being in the shared infrastructure mode, SDN has to play a role where it can deal with this heterogeneity of these devices and then manage them. So that's another part of the SDN, the evaluation we should ensure. The most important aspect is SDN is also tied with the virtualization. It's managing virtualized pools. So SDN should, how much of these policies and decision making you are bringing from these physical aspect to the virtual aspect of your network. So which is your switch, your hypervisor, and then the kind of functionalities and then control hypervisor provides. And the implementation, the SDN having a vSwitch, the entire policies, and then basically the vSwitch stack aspect of it is also part of evaluation. So for example, Microsoft, we have our own vSwitch, which get extended by Cisco, Five9, all these companies which provide different values. Because Cisco wants to talk to their the actual physical switch, so they have extension, and then they can control the switch they want, but it's still bringing those policies back to the virtual network and then controlling the switch. So these are different kind of aspects other than the performance and scale for the SDN.
So the question was in the context of how do you evaluate SDN network elements and controllers. And when it comes to evaluation, we need to know what metrics are we talking about. And so common metrics that people need to know and understand are aspects of the overall policy. How is it conforming to the policy or not? That's one. Access control, who has access to what, when, how, and why. Throughput aspects of point-to-point communication, point to a center, hub and spoke, any kind of network layout that you might have. How is the throughput performance going on? Being able to measure that is also important. Then in case of carriers, this other aspect of quality of service, to be able to differentiate and provide variety of levels of service based on the application of the usage type that's flowing on the network is also relevant. Things like being able to flexibly change based on what you want, based on time of day, based on business, based on applications. These needs to be the metric that we need to go and measure, and how SDN can actually enable evaluation of these metrics is a question that needs to be answered. We don't have a solid answer for each and everything in the industry today right now, but the goal is to be able to get to that point, and being able to identify and measure the metrics that are relevant to the business is the ultimate goal to be able to accomplish eventually.
I think the most important aspect of this question is defining what it is you want SDN to do for you. It's the definition of how much does it need to scale, how many flows, for example. If you don't define what you want your first SDN application or your intro to SDN to be, you're not going to be able to find the right equipment to make that happen. So defining it is not a simple thing by any means, because there's so many different things you have to take into consideration. So I mentioned scale, but the security aspects and the reliability and availability of it, and which controllers you want to use, and all that. So once you know what you want your SDN to do, then you could go out and you could start to look for the components of SDN that will be able to meet your expectations.
All right. I'd like to have an opportunity for you to ask some questions here. Raise your hand, and I will actually let me come to you. And you can tuck into my lapel, actually. There we go.
So historically with networks, you've had actual physical devices, be it a firewall, an IPS device, and you've had security powering that, be it dropping bad IP traffic, so IP reputation, or maybe offering some kind of URL filtering for outbound security cases. How do those, physical devices, it's not a physical device anymore in the SDN world, but how does that concept work in the SDN space? Does that make sense?
Well, it could still be a physical device. So one thing, there was possibly going to be a question about network function versus network function virtualization versus SDN. They are different. So SDN does not imply that any of those middle boxes are software. They can be, but it doesn't make that implication. Network function virtualization does imply that the middle boxes, such as firewalls and load balancers and that kind of stuff, are implemented on a software basis. In fact, something like OpenStack could light up a virtual machine, load like Brocade Viata on it, and then you have a router, and then kill that router when you're done using it, as well as all the network connectivity that is required to make that happen. That exists today, right? I don't know if I answered.
Sorry. And I see is again, how the virtual networks, which is the overlay networks, brings a concept. It's the services which tenant uses on the enterprise side, whether it's a firewall, DDoS, IPS, and IDS devices. And there are ways, the industry is moving towards where you can go to the public cloud and then still bring your own services. That requires a shift towards making those appliances go virtual, but that not necessarily really mean you cannot deploy a physical appliance. Most of the shared infrastructure will not allow it, the tenant to bring the physical appliance, but if you are dealing with a private cloud, you could do that as well. And then from the Microsoft side, we are thinking about, because this multi-tenancy concept is coming, which is new to the appliance world. The appliance world delivered in a form where it's serving a one enterprise need. Now the shift is with our platform, how we can deliver the multi-tenant appliance. It doesn't matter whether they are in the physical world, whether they are in the virtual world. Ability to have that appliance in either form, supporting the different tenant needs, which is at times you would have a huge overlap of policies, but is still providing the isolation and then security aspect of it, that appliance. That's another shift we are going for it. The concept to bring in services are NVF, the service insertion, and then there are many standards going for it. So yes, this is still possible with the virtual world and SDN.
My question was more generally about security and just some of the concerns with SDN surrounding security, and then your views on how to overcome those.
So let me just take assume the question is more because of the SDN also allows the shared infrastructure environment and then multi-tenancy of it. The network virtualization, which is a first layer of overlay networks that protects the isolation which was provided by the MPLS on the VPN L2 world, where carrier lets you have your branch and sites connected across the public internet, and then by providing the VRF and then having a route isolation out there. So overlay networks on the traffic isolation absolutely guarantees. Basically, the blue tenant traffic is not mixed with the red, or the Coke traffic is not mixed with the Pepsi. So that's on the isolation aspect of it. There is another aspect of it, can I put my security needs and then still protect the way I would protect if the entire network is in my control? And that's what goes to his first question is about, can I bring the choice of appliances? Can I put my choice of policies even though I live in a shared infrastructure world? Yes. I mean, that's also possible with the SDN. And then the changes are required in the SDN stack, changes are required on the appliance side of it. They need to think this new world of shared infrastructure, multi-tenant aspect of it. So yes, I mean, like, the virtual network. In fact, like, from the Microsoft side, we provide a multi-tenant gateway. It's a virtual multi-tenant gateway where in the same gateway machine, different tenants can connect securely over a VPN tunnel to an on-premise network. So it's like, the same one, and then you can connect. This is one example of, like, still maintaining your edge policies and your connectivity policies.
Okay, I think we have time for one more.
Let me answer the question in the context of a specific example of, let's say, the financial services industry, where they have this virtual firewall. Actually, used to be physical firewall, with the investment banking side and the regular banking side were separate, isolated, different people, different machines, different data centers, completely all together, and a physical wall dividing between the two. And SEC mandated that you need to keep these things separate. Now, advent of SDN brings along a new proposition for these entities in the banking industry, where they can now see the value of consolidating their both sides across the firewall and still be able to go back to SEC and say, here is the evidence that we have that completely isolates the two sides of banking, and here is how we actually implement, and it is auditable. So SDN does allow industries that require isolation, like in multi-tenancy as an example, or banking industry is another example. So you can go in every single situation where you can enable such isolation and prove it to somebody like the agency SEC for your industry that regulates you, that it is indeed isolated and the aspects of security can be audited and provided as evidence to satisfy the requirements of security that you have.
So did you mean applications of security, or if the controller becomes compromised, how that would? Is that what you, well, I believe that Open Daylight, which is the road the Brocade's going down, the platform is hardened, right? So they've taken steps to make it difficult to be compromised, and all communications and connectivity to devices that it speaks with is all encrypted and authenticated. So you can't just connect a device up without it being authenticated, and you can't communicate to the box as a user or as a program. Likewise, it's also encrypted and authenticated. So that helps. Right?
All right, I think one final question here.
Sure, thanks. So many questions, so little time. One for the Microsoft panelists and one for the Brocade panelists. For the Microsoft panelists, will Microsoft come out with a commercial SDN controller that works with and competes against the folks at VMware? And then for the Brocade panelists, what are your thoughts on the hardware flavor of SDN from the folks down in San Jose? Cisco.
Got the mic, please?
There's no way I'm gonna comment on what we are gonna come up, okay?
We're among friends.
Yeah. If you say, like, whether Microsoft has seriously considered controller as an integral aspect of SDN story, then our answer is yes. We consider controller is integral aspect of the SDN story, whether we partner with it, whether we come up with our own, or do something else. Like, we are a partner in the Platinum partner with Open Daylight as well. So yes, I mean, we consider controller as part of our end-to-end solution. We'll see whether we'll come up with our own and then, like, compete with our friends VMware and Cisco, or partner with them. We'll decide.
So as far as hardware goes between the two companies, I don't believe that Cisco is any more serious about SDN than Brocade. I mean, we're very serious about it, and we're driving forward. We have a lot of engineering resources, and we're developing product. So we have great product and very innovative ideas.
Okay, here's the final question.
So coming from a carrier perspective, we understand and we've heard the word flexibility. So I understand having bandwidth on demand is being very important. What else do you see being very important coming from a carrier like an Integra or our competitors being available to, or being made available to our customer and user? That's clear enough.
I mean, I'm still struggling for the right answer over here, but from the career perspective, some of the examples which I got exposed to as part of my engineering and working on a different products, what we believed in, there is some integration is required from the carrier terminating edge and where your data center edge begins, and the solution that let connect different needs of our customers. We need to work with the carrier. For example, there are customers who require, or tenants who require a bandwidth of 10G over the internet. And those, who could, afford a dedicated line from the carrier and then get terminated, whether through a cyber hotels or whatever the next available spots for them is, and then get back to the data center like Azure or a hosted data net center. The need is there is to find it out a way to connect these two worlds, and then the products and then a standard would help it there. There are already technologies like MPLS, GRE, and all those edge, and we are kind of adopting towards those existing technologies and then working with the carrier. The second aspect of is giving some information to carrier. For example, if data center detects there is a denial of service attack or it's not a dynamic, but it's still in the nature of where it's intent to take down some of the services. We want to have a close integration with the carrier where our policy can provide enough notification or alarms or something that can block these kind of spurious or coordinated attacks, and then that might require coordination across different carriers or working closely with a specific carrier or the internet carrier which the hoster owns it. But these are the different aspects I see the work is needed and joint collaboration with our carrier partners.
So from the carrier's perspective, I'll probably throw in an example, a recent example of Comcast, Netflix, QoS, new contract, that topic that people are aware of. And the struggle carriers have been having up along before SDN, before SDN solutions come along, was that if I want to roll out new feature sets, I need to go talk to my vendors of components, network components, and they will then go study the RFC from IETF. There are 6,000 of them. Implement it eventually 2 years down the road, and then we'll have a solution that might meet your need. That was the case. Now come along SDN. Now you have deploy a small team, have them focus on programming the SDN infrastructure, come up with a solution in 6 weeks, and roll it out. That agility is what SDN brings to the carriers. And I think that's the aspect that I'm optimistic where our carriers will stand to benefit from this new technology as it progresses.
I think for a carrier, SLAs, right? So SLA is very important. You have to meet your SLAs. I assume that you probably go into a contract with your customers. And in order to meet that, you might be able to gain, with the SDN, you could gain visibility, maybe prevent distributed denial of service attacks, other security things. You can also deploy new services. So let's say you're going to come up with some type of new service, deploy that, bring it to market quicker. You might be able to resolve issues faster with a centralized intelligence than distributed or no intelligence at all. And if your customers want to deploy new services that you're already offering, the service chaining aspect of SDN can maybe you'll do a firewall or a load balancing or something like that, and be able to put that in just through a portal or a provisioning platform of some sort, or or some software.
Please, round of applause for our panel here.